Hey everybody, it's Jason Cardiff here, the CEO and co-founder of Cleano2 Carbon Capture Technologies. So here we are, it's Friday, January 25th, and we are on the first day of our 1 ton challenge. Now, I have a confession to make. I've actually been recording video from the first previous days of this week, just to kick things off and to have something to actually show you. So while the official kickoff date of the 1 ton challenge is today. We've actually been recording data and video for the last couple of days, and we'll be releasing information as we go on a weekly basis. Now, what is the 1 ton challenge? The purpose of the 1 ton challenge is to demonstrate to everybody, from investors to customers to friends and family or curious onlookers who just want to know more about what we're doing, of showing the value in carbon. As most of you know, the purpose of our technology is to scrub carbon dioxide from the flue gas of heating appliances, particularly commercial and light industrial heating appliances, and converting that flue gas into a commodity that we can sell in the open market at a profit. And then to incentivize people to get on board with us, we want a profit share with our customers so they get their return on their investment for the initial purchase of our technology, as well as an ongoing revenue stream, free preventative maintenance schedules, and all of the good stuff that comes along with having us in your mechanical room. So we really sort of want to add transparency to how we operate. Everything from loading up the chemical, putting it into the vehicle, driving to location, collecting the byproduct, bringing it back to the shop, weighing the amount that we're producing, and then we're going to help sort of showcase what it's like to go through the process of selling it to industry and communicating with who we're selling it to and where the byproduct is going to. And then, of course, we're going to finish off the 1 ton challenge and by cutting a check to both our customers, ATCO Gas, as well as the Garrison Woods Condo Association, for their share of the profits that we've generated from the sale of this byproduct. So we're very excited to do that. And to be honest with you, we haven't done it at scale before. We've made small batches of sodium carbonate. We've recently switched everything over to potassium. We haven't done it at full scale. So we're really interested to do this. We have the pathways in place. We believe we can do this in a very quick fashion. And we want to be transparent with you and show you that we can do this. The video you're about to watch is the collection process that occurred yesterday at the Garrison Woods Condo Association. And if you have any questions, any comments or concerns, any advice that you can give, or any connections that you think you could maybe that might actually help us along our pathway of, once again, showcasing the value in carbon and trying to develop a strong Canadian presence in the carbon tech industry, feel free to post your comments or reach out to me. I think I'm a pretty approachable kind of guy, so as are the rest of our team members. So yeah, sit back and enjoy, and I look forward to sharing this story with you. Thanks.
All right, here we are. It's the day before we're officially launching the 1 ton challenge, which is basically the processing of 1 metric ton of potassium hydroxide to see how quickly we can plow through that 1 pallet of chemical between 2 units, one at the Garrison Woods Condo Association and the other one at the ATCO Whitehorn Compressed Natural Gas Fueling Station. We're just doing the one location today to demonstrate the amount of time that it takes to complete a cycle. And so we're going to time it from the time that we left the shop. It looks like it's 2:18 p.m. on Thursday, January the 22nd? What date is it today? I can't remember. 24th. Today is January 24th at 2:18. So we've loaded up the chemical in the back of the vehicle. We're going to head straight over to Garrison Woods. We're going to vacuum out the load that we put in 7 days ago, reload it with new hydroxide, bring it back to the shop, offload it, and time it and see how long it takes. All right, here we go. Good times. Okay, so we've arrived on site at Garrison Woods. It's now 2:37. This was the very first location of our commercial unit, our first prototype that we put in. We've replaced it a couple of weeks ago and made some modifications and some improvements to the efficiency, and have had it running for a couple of weeks, I guess since the 7th, or perhaps it was the 10th of January. So we're just going to go inside the room here. And you can see the unit is up and running over in the corner, which is great. So now we're going to go and take a look at the inside and make sure that it's ready for collection. We should be able to tell that just by the consistency of the byproduct. So hang tight, we'll open it up and take a look. Always important to make sure you turn the thing off before you open it up. There's two switches on the back of the unit. There's a 3-phase disconnect and a 120 disconnect located at the back of the unit. There's also an interlock on the front of the door so that if you happen to forget to turn it off, it won't start agitating chemical while you've got your hands in there trying to suck out the byproduct. Let's open it up and take a look. Alright, if you take a look inside here, you can tell this is a nice, good, nice powdery type consistency. No chunks. When it goes in here, it's large flakes. It's pretty dry. We look for to make sure that when we squeeze it, pull it together, it doesn't clump. The nice thing about potassium is that it doesn't clump like sodium does. Sodium actually clumps a fair bit, so it's a lot more difficult to process. Always good to make sure you're wearing latex gloves when you're dealing with this. You could put your bare hand in here. It is an irritant, and it doesn't burn obviously like hydroxide does. If you're like me and you've been in the industry for over 20 years, the calluses on your hand tend to act as some level of protection, but always good to play safe and make sure that you're wearing the appropriate gear when handling chemicals. So let's get to it. Let's get the system set up. We'll bring the buckets in, vacuum what's out of here. We're going to measure it, record it in the logbook that's on site, and reload it back up with new chemical and get back to the shop, see how long it took us. All right, here we go. All right, so we've weighed the 8 buckets. The numbers varied from 23.35 down to 20.95. I tallied the total of weight that we achieved here, which was 177.45, and then I counted 1 kilo per bucket, so negative 8 off of that. So we ended up with 169.45 as our final number, and that's a record. The one we just set from the Atco location a couple of days ago was 118. So 169.45 is a fantastic number. So we're going to record these numbers down here. Let's see, today is, what did I say the date was? Today is I can never remember dates. January 24th. Okay, output was 169.45. We'll carry that over, 169.45. And we were going to put in, we have 6 bags that measure 25 kilo a piece. So that's 150. So we need to remember with these chemicals, the transition between potassium hydroxide and potassium carbonate mean that it's gaining weight from the additional carbon that it's picking up. So the ratio is about 1 to 1.23. So for every 1 kilogram of potassium hydroxide, you get 1.23 kilograms of potassium carbonate. So that's the way that works. Now there's some moisture content perhaps in there, although I suspect the moisture content from the looks of it is probably less than 1%. It doesn't clump, it seems pretty dry, and you can get a little bit of a static charge from vacuuming it out, and I always thought that was kind of a good way of measuring the dryness of the material. Whether that's accurate, and I don't know. We'll do some further tests on it to do actual moisture contents and purity contents. Kathy Fisher, our chemist, will be doing a titration test to determine the purity of potassium carbonate in it as opposed to the potassium hydroxide. But the numbers that we're pulling out of this vary in around, I think around about 98 to 99% pure. So you have to excuse me, it's a boiler room, it's hot, I'm wearing a sweatshirt. That was a really stupid idea. It's cold outside, but you know, it's like you got to wear two outfits when you're working in mechanical rooms. The cold outside weather and something less warm than what I'm wearing right now. So, all right, well, this time's ticking. Let's wrap this up. I'm going to do a little bit of house cleaning here, clean up the floor, reload it with 6 bags. I'll take another quick video here once it's all loaded up. We'll get in the truck, head back to the shop, and we'll see how long that took. All right, good times. Whew, hard work, love it. Let's take a look, shall we? Sweating like a pig. You know, I should add, you know, I know this seems like hard work to some of you, but let's face it, this industry was built on hard work. The heating industry is all about getting in there, getting dirty, getting things done. So, you know, I don't mind working hard, and there's lots of guys and girls just like me who don't mind going out and getting a sweat on it. As I've said in previous posts, who needs a gym membership when you can come into a mechanical room and work out? So let's take a look inside. So that is 6 bags. That equals 150 kilos of potassium hydroxide. Now, as you noticed, we'll end up pulling more out of it than we put in, and it's because of the chemical reaction. Now, typically you would think that if you're putting in 150, you'd be getting closer to 180 kilograms of potassium carbonate out of this load, but you know, I'm spilled some on the floor, some still in the vacuum, some still in the chamber. So it's never 100%, you know, 180 kilograms every load, but you know, as long as we're showing that we are increasing our mass, that's good. So I got some sweat in my eye, and my eyes are starting to sing, so I'm gonna stop now. All right, we are back at the shop. Just have to offload the buckets. We're gonna take a couple of samples out of there so that Kathy can test purity of the byproduct to make sure that we're providing a quality product. Overall, what time is it now? Okay, so it's 4:11. I just got off the phone, so I was chatting for a little bit, and then I had a couple of meetings between here and there. So it took a little bit longer than anticipated. I think we left at 2:30. It's now 4 o'clock, so that's an hour and a half. We'll say an hour and a half. It should have been closer to an hour. I think we can do it in an hour time from including pickup and collection and return to the shop. Now, typically, once you had finished picking up your chemical, you would be going off to your next location to do a collection. So probably next week or perhaps the following week, depending on how long it takes to process the batches that we have in both units. We'll do both units at the same time so that we can show, you know, what multiple units look like from a collection standpoint. So I'm going to go and take these buckets. I'm going to put them in the super sack after I take a sample out for Kathy to test, and call the day a success. It's great. We've got a new record for the biggest batch at 69.78, I think it was, in potassium carbonate. The quality looks pretty good, and of course that'll be supported by the test that Kathy is going to do tomorrow. So stay tuned.